Okay, next we're going to talk about catalog-based testing. Beforehand, we've talked about combinatorial testing and pairwise testing. And what's going to happen next in the catalog is we're really going to lean on the experience of test designers by listing important cases based on the inputs. For example, if something's using an integer, it's very common to test the element preceding the lower bound, at the lower bound, somewhere between the two bounds, upper bound, and then something just following the upper bound to make sure you test for all those cases. I usually like to throw in 0, 1, int max, and int min as well, just to be that way. But the idea is that we're going to try and leverage how most people actually have been testing for a while through experience to know what type of errors are very common to come up with some good errors. So when you're doing catalog-based testing, you want to come up with step one is actually do the analysis, which means you need to have your preconditions. Those are the conditions that exist before the program runs. Post conditions, what needs to be true when the program exits, and then any definitions that or variables that are going to be used or operations, just so people are clear on what's going on. And then step two is derive the first set of test cases from precondition and post conditions and your definitions. And then last, complete the set of specifications using test catalogs. And this is really to fill out the test and also to simplify it somewhat. The example they come up with, which is a little confusing, is CGI decode, which translates anything that's CGI encoded back into ASCII string. All right, what is this CGI encoded? Well, if you recall, when you're going through the web page, sometimes when you visit a web link, you look up in the browser and you might have this, percent a something or another, which represents a certain character. And that's what a CGI encoded string is. It also translates spaces into plus as well, and most other non-alphanumeric characters to hexadecimal escape characters. That way they can at least be somewhat readable. So the input here, and decode is just going to take it and then decode it into the actual ASCII string. So your input is, of course, a CGI formatted string. It's going to be alphanumeric characters, followed by that may include the character plus, as well as some %xy, where x and y are hexadecimal digits. And then your output is going to be the string of character in plain ASCII, where they've taken all the alphanumeric characters, copied over a blank for each space, or plus, aka space, and a single character value with xy for the substring %xy. Your output, also the other output that you're going to have, notice this program is going to have two outputs. One, the string, is the other one's a return value, where 0 is success, and 1 if it's somehow malformed or didn't work out. Alright, so I went over preconditions, but these are something that must be true before execution. You can validate some of them, and others you just have to assume. It's best when you do this type of testing that you actually write it out. So you want to first do your preconditions. Notice here, your first one's assumed is that your string is encoded in null terminated string of characters. Usually a good assumption. It's hard to test that otherwise. And then the other one, which is something you can validate, is that it has been encoded in a sequence of CGI items. Post one is basically the output will contain all the alphanumeric characters that should be copied directly. Post condition 2 is all the pluses have been replaced by space. 3 is if it contains hexadecimals, they are replaced by the corresponding ASCII characters. 4 is if it was processed correctly, return 0. 5 if it contains a wrong hexadecimal, something that's not in the range, return 1. And if it encounters any illegal character, just return 1 as well, aka those are errors. So variable 1 is usually one variable using a string of ASCII characters that are going to be encoded. Variable 2 is a string of ASCII characters that are being decoded. And then 3 is the return value. Some definitions: hexadecimal character can be from 0 to 9, A through F, as well as little a through F. And 2, %xy is a sequence, we're going to call it, or x and y are hexadecimal, and then CGI items are all the alphanumeric characters, or plus that is a CGI hexadecimal. We'll just say for sake of argument there's 15 of them. Okay, so validated preconditions. These are simple ones. You have something that satisfies precondition or doesn't, so you want to write a test case that either does or does not, and you can usually combine them in order to simplify your code, your test cases. Let's see, post conditions. If given a conditional expression, consider expressions as if they were valid preconditions. Right. So what they're going to do here in their specification is they're going to take their precondition and then come up with basically a test condition for precondition. One encoded is a sequence of CGI items, so you can test for that, or if it's not. So one is basically saying true and two is not. Notice you do the same thing with post. One, it contains alphanumeric or does not for two, and everything that's been encoded with a plus becomes a one. Notice that these are preconditions for CGI on the encoded string. If encoded contains hexadecimal, they are replaced by the corresponding ASCII, again for the either the encoded input contains the hexadecimals or it doesn't. If encoded is processed correctly, return 0, or there's not too much we add to that. And then if it's encoded contains a wrong hexadecimal, then contains, we're going to say 5-1 contains an erroneous CGI one. And post 6-1 contains a legal character. So we're just giving this a label for now. Variable ones are still good, and the rest of our definitions have not changed. So now we've come up with a good long list of what to test with. We need to apply the catalog. Usually you want to go through this catalog that you've just created sequentially, and for each element, scan the spec, and then apply the entry. So for example, if you have a Boolean, then two test cases come out, true and false. Label in and out only if applicable to input output. So first we're going to come up with this catalog. So a simple catalog. If you have a Boolean value, it can be true, and that can be an input or an output. False, again, input and output. Enumeration is any enumerated value, in or out. Some values outside the enumerated set will be in. What it's saying here is if you have a value that's outside the ASCII chart, your ASCII, it should only be on the input because that's what CGI is. It should not be on the output. The ranges from lower to upper, if it's one less than lower, should only be on the input. Otherwise, in and out, etc., etc. And then same thing for a numeric constant C. Then continue on with this for a while. But let's just dissect Boolean for now, because that's going to be the simplest one. Boolean in out for both true and false can be a return value, so it generates two test cases covered by precondition 2.1 and 2.2. Notice that those that we're talking about back here, I don't think I made that clear. These are actually test cases that you would come up with. So these are the test case post 3-1, test case post 3-2. So we already have these test cases. So what this is saying here is as you inspect this, but they're already covered by some tests of some preconditions, so you don't need to write them again. Enumeration, again, these are already done, tested, and are different post conditions as well. Some new test case specifications. So we might want to come up with entry enumeration for encoded with a %x but no y. So that might be test case post 5.2. Another one for 5.3 ky where k is not a hexadecimal, so that's another test case. 5.4 xk where again xk is not. So those are three different new test cases. Old test case specification can be eliminated if they're less specific. So 3.1 encoded contains hex, and also 5.1 contains erroneous one. So we kind of eclipsed these by adding these three. So we added 3, took away 2, so we only netted 1. It is good to go back and basically remove some test cases that are no longer needed, and this is very common. All right, entry range. I'll try and explain this one. Applies to the variables defined in a finite range. For example, hexadecimal digits, you need to test for a slash and a colon. Why? Well, they're before 0 and after 9 in the ASCII table, so that's lower and upper bound test cases. Don't forget to put one between 0 and 9, so that's 3 test cases. At, G, A, and F, so those are the bounds for, or one value between A and F, so those are the bounds for uppercase, so that's another 5. And then same thing with lowercase, so that's another 5 as well. That hopefully came out to 15, and then 30 new test cases for the different characters that can come out with the CGI. And then your alphanumeric, another 5 new test cases. If you were to go back, that just has to do with the definition of CGI. Let's see. Entries, numeric and non-numeric constants does not apply. Non-numeric applies to % and plus in definition 2 and 3, but if you actually go through all these non-numeric constants, we've already tested, so they're all redundant. All right. hopefully you see what's going on here. They're simply going through and trying to go through every single definition, see if they can come up with any new test cases, and if they do, does that make any of the old test cases redundant? If so, eliminate the old ones. And they're going to continue doing this for different entry sequence, etc., etc. And here's a summary of actually their final generated test cases. All right. What have we got so far? So category is a good manual step for putting them to categories. Is a common step. From catalog-based testing, which is what we did, we have recording and using standard patterns that we have adopted over time and apply it. And then pairwise is just a systematic way to come up with different testing. Naturally, all these ideas can be combined to try and come up with a simple test suite that tests as much as possible without having to be overly redundant. All right, hopefully that gets you the idea of what's going on with combinatorial testing.